Hey everyone, how it goes, and welcome back to Computer Science 145. Today, we're going to continue discussing classes and objects. In a previous lecture, we started going over code organization. We used this in order to reuse parts of code, so we use less statements, quickly find bugs and errors, and easily extend or add functionality to our programs. Java organizes software first inside of projects, then inside of classes, and then inside of methods. We're going to continue our discussion about classes, and classes are a way that we can create classifications of objects. Instances of a class is referred to as an object. And what classes do is provide a blueprint of a class of objects. So in other words, it groups together shared qualities and shared characteristics. In terms of programming, classes combine data, in other words, attributes or properties, along with methods, the actions. It is a good idea to start thinking of classes as nouns. Anytime you're starting to develop software, if you notice that you're using a noun, it might be a good idea to create a class. That way it becomes a classification of these nouns. And also remember back, methods act as actions. They are the verbs. So for each one of these nouns, they have a series of actions that they can do. It was also recommended in a previous lecture that if you're creating a class, follow these 7 easy steps. Step 1, define the class. Step 2, create the properties, instance variables, and constants. Step 3, define constructors, a default and parameterized constructor. Step 4, create accessors for every instance variable. Step 5, create mutators for every instance variable. Step 6, create the other methods. 2 recommended ones are equals and toString. And finally, step 7, use the class to create objects. Now, let's see another example about how we can create a class. In a previous lecture, we went over how to create a class called a cat. And we also showed how we can use that code to dynamically allocate instances called objects in order to create those cats. Well, today what we're going to do is expand our horizons a little bit. Maybe we just don't have cats. Maybe we have other types of pets. So what we're going to do is create a manager to keep track of all the pets that we have. Well, as I keep saying this, I recognize that pet is a noun. This tells me that this might be a good class to create, because we can have several types of instances of these different pets. So if we create this class, this classification called pet, we can then create the objects from that class. So let's first start out. Step 1, we need to define the class pet. How I'm going to do that is create the class, name it pet. And now we've done step 1. We have defined the class, public class pet. The next thing I'm going to do is put my name at the top here. And also, as I go along with this, I'm going to put down each one of the steps. So this is step 1, define the class. Now we have step 2. Create the properties. Now the properties could be instance variables or constants. We're going to focus more on the instance variables. This is the information that's associated with each one of the instances of a pet. So in other words, what information do we want to keep track of for every one of these pets? Well, thinking about it, I need to keep track of the pet's name. So what I'm going to do is create an instance variable for the pet's name. Now, instance variables, their scope should be private. We want to safeguard this information. We want to hide it away and make sure that if we're going to modify this information, that it follows our guidelines. The idea of information hiding is called encapsulation, and it's one of the first principles of object-oriented programming. So going back to this, we need to create a name. So what type should the name be? Well, it makes sense to create a string and use the identifier name. Thinking about this some more, another property I should keep track of is private int age. How old is the pet? Now, thinking about this a little more, another property I should keep track of is private double weight. And now, as I'm thinking about this further, keeping track of the name, age, and the weight is important, but I also should keep track of whatever the type of pet it is. Now, I know the scope should be private, but what should the pet type be? It would make sense to create a string. But hold on a second. Maybe there's only a certain number of types of pets that I could have. Now, a string could be anything, but if I have a set number of types this could be, then let me introduce a brand new concept. This concept is called enumerations. Now, an enumeration, or an enum, is a special kind of class that only contains constant values. Now, it's a good idea to use this when creating a type that only has a set number of potential values. As I said before, there's only a couple of types of pets that I could have. So while I could use a string, it makes more sense to use an enumeration instead. Now, when creating enumerations, they're just like classes, and it's good programming practice to create them in a separate Java file. So much like classes, you start out with public in its own file, but instead of class, you use the reserved word enum followed by its identifier. Then inside the body of the class, in other words, inside the curly braces, you have each one of the values separated by a comma. Now remember, an enumeration contains constant values, so all these values should be capitalized just like other constants. Now, as an enumeration is a special kind of class, it doesn't require construction, and you can access the values simply by using the dot. So whenever we are going to use an enumeration, we set it up just like any other variable. We use the enum identifier followed by an ID, and then if we're assigning this to one of those values, we use the enum identifier, the enum's name, dot, and whatever the value is. Once again, enumerations are excellent to use when you know a type only has a set number of values. We could have used a string. However, since we know this can only be a certain number of values, we can use an enumeration to do this much easier with less error checking, and in fact, it's a little faster and practical efficiency than checking the values of a string. Now with that being said, let's create an enumeration. Now going back to the code, what I'm going to do is this time I'm going to create a new enum. Now what's this enum's identifier going to be? Pet type. And now we created the enumeration called pet type. So what kinds of pets can I have? Well, we can have a cat, we can have a dog, we can have a hamster, we can have a hedgehog. For some weird reason, we can have an armadillo. We can also have a turkey. We can have an owl. And the strange thing is, we can also have another kind of pet, even if we don't really know its type. So we can have an unknown pet. So these are the types of pets that I could have. And once again, I'm going to put my name at the top here. Now going back to my pet class, now what I'm going to do is use that enumeration. I'm going to create a private. Now the type is pet type. And I'm going to use the identifier type. Now once again, we could have simply just used a string, but I chose to use an enumeration because the types of pets that I could have are only cat, dog, hamster, hedgehog, armadillo, turkey, owl, and maybe an unknown type of pet. You'll see in a little bit that this makes it a lot easier when we get to error checking, and also once again, in practical efficiency, checking the values of an enumeration can be faster than checking the values of a string. In certain programming languages, enumerations are treated as named integer values, and it is much faster to check the value of an integer versus the value of a string. Now, let's get to step 3, create constructors. Constructors are a very special kind of method. They're usually public, they do not have a return type, and the identifier of a constructor has to match the identifier of a class, so public, pet. Now there's two types of constructors that I recommend creating. One is called the default constructor. First of all, the default constructor has no parameters, and its goal is to set each one of the instance variable values to some default correct value. So I'm going to use the reserved word this. This is considered the self-referential pointer. It basically references this instance's variables or also this instance's methods. We're going to worry about instance variables, so I'm going to call this .name, and I'm going to set the pet's name to none at first. Then this .age, we can set that to 0. This .weight is equal to 1.0. And this .type is equal, well, now we have to pick a default pet type. Once again, to use an enumeration, which is basically a special class of constants, we use the name, the enumeration's identifier, pet type, dot, and let's say the default value is unknown. And there we go. That's our default constructor. Now I'm going to create another constructor, public pet. Once again, it's public, no return type. And this one is going to be the parameterized constructor. We use a parameterized constructor to both construct a new instance of this class, but also set all of its values. So this requires having a parameter for each one of the instance variables. So the first one is going to be string, an for a name, int na for an age, double aw for a weight, and pet type at for a type. I'm going to come back and rewrite this, but for now I'm going to write a to-do use mutators. If we are constructing a new instance of this pet, and we're giving all the values to be assigned here, we also need to check if those values are correct. This is something that we do inside of the mutator. So instead of doing the error checking inside of here, what I'm going to do is write the error checking inside the mutator and then just simply call the mutator. This saves us time because we have to write less code. We could simply use something that we have already written. But as we haven't written it yet, we'll come back and do that. Step 4. Create accessors. Each one of the instance variables scope is private, so we have no way to access any of these values outside of this class. Now, if we determine that we would like to give access to these values outside of the class, then we create an accessor for those values. For right now, we're going to create accessors for every one of the instance variables. Accessors are very formulaic. First, they're public. Then, I'm going to create an accessor for name, And the return value of an accessor has to match the type that this value is. So public string, accessors usually start with get, followed by the identifier, name, and accessors have no parameters. You don't need to give information to an accessor in order to get that information. Then all we have to do is return. Now remember, as this method has a non-void return type, we have to use the word return in order to return some kind of value. Now I'm going to return a reference to my name, and I'm going to use this.name. And that's how we create an accessor for the name. Now we're going to create accessors for the rest of the instance variables, age, weight, and type, and it's just going to follow the exact same formula. Public int get age. Now we have to return this.age. Public double get weight. Return this.weight. Finally, public. If we're going to get the type, what is the type of type? Well, it's pet type. Get type, and we're going to return this.type. Once again, accessors give access to each one of the instance variable values outside of this class. They start out with public, whatever the instance variable type is, get the identifier, and then you just return this dot whatever the instance variable's identifier is. This also includes if we create our own types like this one. Next, step 5. Create mutators. Mutators allow us to modify the values from outside of this class. However, before we modify the values, we have to validate if that value is correct. Mutators have a very simple formula, much like an accessor. They start public void. You're not returning a value, what you're doing is setting a value. Public void set. We're going to create a mutator for every one of our instance variables, so the first one is going to be name. Now, as we have to provide information to the method, we need to provide this information through the parameters. So I need to pass in string an for a name. Now we're going to assume that you can name a pet whatever. However, there is something very special about this case. A string is a class type. Now, as we know, this identifier right here, all it holds is a reference in memory. We understand that there is a very special memory address that we need to look for. In other words, we want to make sure that if we're going to set this pet's name, that this value right here has been created. In other words, we have to make sure that this value is not null. We want to make sure that the name is at least set to something. So if an is not equal to null, now notice, yes, this is a class type, and it's always been recommended that you use the dot equals method in order to compare the contents of a class type. But we're not comparing the contents, we're comparing the memory address. This is why I can use not equals or double equals to compare it to null, because this is a memory address. And this is a special memory address that means nothing. It means it has not been created, it has not been constructed in memory. Now I'm going to do this in kind of a different way than you've seen before. I'm not going to put the curly braces, I'm simply going to write this.name is equal to an. In a previous lecture, it was recommended that anytime you write an if statement, an else if, an else, a while, a do while, and a for loop, that you put the curly braces to indicate the body of that type of statement. However, if there is exactly one statement inside the body of an if, an else if, an else, a while, a do while, or a for loop, then you can omit the curly braces. And I'm going to do this, that way we save some time in coding. Now the next thing I'm going to do is write else. Now if this was null, we want to make sure that the name is set to something. So let's just set it to the default value, this dot name is equal to none. Mutators allow us to modify values from outside the class, but if we're going to modify those values, we need to validate if that parameter is even correct before we set that value. It is a good idea to error check because you want to make sure your code behaves the way that you intend it to behave. Now let's do the same thing for age. Public void set age int NA and age. And now we need to validate whether or not this parameter is correct. So if NA is greater than or equal to 0, then we're going to set this dot age is equal to the parameter NA. But if that's not true, this dot age is equal to 0. Next, public void set weight double AW. And in this case, if AW is greater than 0, then we can set this dot weight is equal to AW. Otherwise, this dot weight is equal to 1, the default value. Next, public void set type. Well, we need to pass in an instance of a pet type, AT. Now in Java, enumerations are a special kind of class. And just like the other class types, I need to make sure that this even exists. So the first thing I'm going to check is if AT is not equal to null. Then I can set this dot type is equal to AT. But otherwise, if it is null, we still need to set it to something. So we're going to set this dot type is equal to the pet type unknown, as that was the default value. Then we get to step 6. And this was the other methods. There were two in particular that I heavily recommended that you write always. ToString and dot equals. Let's start with ToString. It starts public string ToString no parameters. The purpose of this method is to return a string that is related to this instance. What I'm going to recommend is you return a string with all of the properties concatenated together. So return this dot name, and to keep it simple, we'll just add a space. Then we're going to add this dot age, add a space. Then we're going to add this dot weight, add a space. And then this dot type. Now we could also make this look a little nicer, but we're just going to keep it simple for now. The other method is equals. Now as this is a class type, if we want to compare the values, the contents of this, then we need to use a method in order to do that. So what we're going to do is create this equals method to check this pet's name, age, weight, and type versus another pet's name, age, weight, and type. Dot equals starts out public boolean and then equals. Now what am I comparing this pet to? Another pet. We'll say AP for another pet. Now the way that we're going to do this is create a compound Boolean expression that checks all the properties. So first we're going to return. The very first check you need to make is just like every other class type. You need to make sure that this even exists. So AP is not equal to null. If basically we're comparing this pet to nothing, then of course they're not equal. This is going to evaluate to false initially, and then it's just going to ignore the rest of the checks, as Java short circuits. Now after we have checked if this other pet even exists, now we need to check each one of the properties. And we're going to check this dot name. Now we know that the name is a class type, so we're going to use its .equals method in order to compare this other pet's name. But hold on a second, how do we get this other pet's name? Well, I just said it. We can use the accessor, ap.getName. And this .age. Now, as this is an integer, we can use double equals. As it's a primitive type, it's just a simple value. And now we need to get another pet's age, ap.getAge. And this .weight is equal to ap.getWeight. And this .type. Now here's the interesting thing about an enumeration. You can actually use double equals to compare them without having to use the .equals method. As each one of these are constant values, all we need to do is use this. Now we could call ap.getType. And now this is the .equals method. And we're pretty much done defining this class. Oh, wait a second, there's something I forgot to do. After I wrote my mutators, and don't forget this, make sure you fill in the parameterized constructor, that way we can set these values. So going back to the parameterized constructor, this .setName, an, this .setAge, an a, this .setWeight, aw, and this .setType, at. And now, what I'm doing is I wrote every one of these mutators with error checks inside of it. If I'm constructing this and also setting each one of these properties, I still have to error check. But as I've already written them inside the mutators, I don't need to rewrite them. I'm using the code that I have already written before in order to save myself from writing extra programming statements. Now, the other interesting thing about using this enumeration, not only can we use double equals, and as mentioned before, in terms of practical efficiency, it can be faster than checking a string. Let's take a look at this mutator one more time. Now, scrolling down to here, all I need to check for is if this is null. But imagine if I had used a string. If I had used a string, I would also need to verify if this was a cat, dog, hamster, hedgehog, armadillo, turkey, owl, or unknown. I would also have to include every one of those checks inside of here instead of just doing it this way. Enumerations are great for when you know that a certain property only has a certain number of values. It saves us time in error checking, but it also saves us time in practical efficiency when we have to check for these values. Now going back to the other methods. Now I'm just thinking about what are some other actions we should write inside of this pet class. Now when I'm thinking about these actions, I like to give my pets compliments. So maybe that's an action that we need to write inside of this class. So let's think about this. Let's make this public. That way, giving this pet a compliment is going to be accessible outside of this class. Then it's not going to return anything. We're going to say void. And I'm going to name this method, let's just say give compliment. And let's say that this has no parameters. Now what does the pet do when you give it a compliment? System.out.println, let's say this.name reacted with joy. So with all of this written, what we can do now is step number 7, we can start creating instances of these pets. I'm going to create a separate class because we have these pets and they have pet types. But if I'm thinking about this, we also have a place that contains these pets. Well, that sounds like another noun. This feels like this should be another class. I'm going to go ahead and create a new class called pet place. And I'm going to include the main method, that way we have an entry point into the program. I'm going to remove this comment. I'm going to put a comment with my name. And now I'm just going to create a couple of pets. Pet01 is equal to new pet. I'm going to call its default constructor. Now to just show what happens, system.out.println pet01. When I run this, well, it prints out all the properties because it's assumed this calls its toString method, which returns the string with the name, the age, the weight, and the type. Now what happened here is when we constructed this, it replicated all of this code dynamically inside of memory. So all of this code that's inside of here just was replicated by simply calling this. Now I can create another instance, another object. Pet02 equals new pet. This time I'm going to use the parameterized constructor. I'm going to say, Mr. Flufferkins. Age is 7. Its weight, let's say 8.6. And the pet type is a cat, just like before. System.out.println pet02. Now let's see if this works. Sure enough, using the parameterized constructor, it set the name, the age, the weight, and the type. Now just to point this out again, by simply calling this, we have replicated all the code that's written inside of here again inside of here. We've created a new instance. We have dynamically allocated this new object inside of memory. And we could do that again even. Pet03 equals new pet. Now this one is going to be, I don't know, Rufles. Age is 3, weight, let's say 15, and the pet type is a dog. System.out.println pet03. See what happens? Sure enough, it set all the properties, but more importantly, by using this code, we have now replicated everything. We've copied everything inside of this class over again inside of memory. Now let's try this. Pet02.giveComplement. Let's call this other method and see what happens. Well, Mr. Flufferkins reacted with joy. Now this can be sometimes true for a cat, but in this universe, we're just going to assume that it's true. Now hold on a second. As I start thinking about this more, I'm realizing that maybe I give multiple compliments to a pet. So it's not just like, who's a good creature? But, you know, sometimes you're sitting there and you're talking to the pet and you're like, who's a good creature? Who's a good creature? Okay, you keep saying it over and over again, so maybe I'm not just going to give one compliment, maybe I need to give multiple compliments. Well, the more I'm thinking about this, maybe what I need to do is create a different version of that exact same method, but in this case, we're going to give multiple compliments. Before we do that, let me introduce a new concept. Now, first of all, a method's identifier, return type, and parameters is called the signature or the definition of a method. We can do what's called overloading methods by using the same identifier, the same return type, but with different parameters. So in this case, what I'm going to do is not just give one complement, but give multiple compliments. How many compliments? Well, I need to pass that information in via a parameter. Let's see how that looks. Going back inside the pet class, what I'm going to do is overload this method by changing up the parameters. So in this case, I'm going to call public void give complement, and this time I'm going to pass in the parameter int c for the number of compliments that I'm going to give the pet. So as I'm going to give a certain number of these compliments, this feels like I need to loop this. How many times? Well, by this given number. Well, hold on a second. If I know the number of times that a loop's body needs to run, this indicates this might be a good idea to use a for loop, as it is a counting loop. So I'm going to create for int I is equal to 0. I is less than c, I++. So if this c was 3, this loop runs I is 0, 1, 2, in other words, 3 times. Because 3 is not less than 3, so 0, 1, 2, that's 3 times. Now hold on a second. I'm going to give basically the same complement over and over and over again. And I've already written the method give complement once before. Well, this isn't going to change. Only thing that is going to change is the number of times that it is called. So in fact, what I could do is reuse this by calling this.giveComplement. Now you may also notice I did not put the curly braces because this for loop has exactly one statement inside of it. Now, for an if statement, an else if, an else, a while, a do while, or a for loop, if it has exactly one statement inside the body, you do not have to put the curly braces. But if you do want to include the curly braces, go ahead and do that. That's part of discovering your programming voice. Do what works best for you. Now going back inside the pet place, now what I'm going to do is pet 03 Rufles, I'm going to give, let's say we're going to give them 3 compliments. Now running this, you can see this printed out 3 times because we used the overloaded version of this other method. Now, in this lecture, we have continued our discussion on classes. We use classes to create instances that we call objects. These objects are dynamically allocated into memory. In other words, the code written inside of a class is replicated inside of memory every time we construct a new instance of that class. We do this to organize our code. That way we end up writing less code in the long run. In this example, we created 3 versions of pets. And all the code that we wrote inside the pet class was replicated dynamically 3 times over. Also, we introduced the concept of an enumeration, which is a special kind of class that only contains constant values. And we use enumerations whenever we know that there is a certain type that can only have a certain fixed number of values. Furthermore, we introduced the idea of overloading methods, where we have the exact same method definition, but a different number of parameters. That way it behaves slightly differently. Now, with all of that being said, I'll see you next time.